Okay, let's take a look at those sum and differences of trig functions of angle things. So here they are again. We have sine of a sum of two angles equals that. Cosine of a sum of two angles equals that. Tangent of sum of two angles equals this. Now, let's look at a very special case. Suppose that the two angles, theta 1 and theta 2, were the same. That could happen, right? I never said they were different. Let's take a look at what happens if I take a look at the sine of theta plus theta. So let's have all the thetas be the same. Well, here I would have 2 theta. Theta plus theta is 2 theta. And what would I see here? Here I'd see sine theta times cosine theta plus sine theta cosine theta. So I'd see sort of this term and itself. So I would see 2 times sine theta cosine theta. So actually that gives me a formula for the sine of twice an angle in terms of just the angle itself. And that kind of formula is called a double angle formula. So all I'm going to do is take this formula and replace the theta 1 and theta 2 by the same theta. So I see sine of theta plus theta, which is 2 theta. And that would equal sine theta cosine theta plus cosine theta sine theta, the same thing. So I see 2 sine theta cosine theta. So in fact, if you take a look at this identity, a special case of it would look like this. Sine of 2 theta would equal 2 sine theta times cosine theta. And where did that come from? Just this formula here, where I put in the same angle for everybody. Well, now I can do this for the other trig functions. For example, suppose I do it for cosine. If I put in theta 1 plus theta 2, and I replace that by theta plus theta, what do I see? I see cosine of 2 theta equals cosine theta times cosine theta. That's cosine squared theta. And then minus sine theta, sine squared theta. So I see a double angle formula for cosine that would say cosine of 2 theta equals cosine squared theta minus sine squared theta. By the way, you may say, hey, isn't that equal to 1? No, no, no. The formula is cosine squared theta plus sine squared theta always equals 1. But their difference, in fact, doesn't always equal 1. In fact, their difference equals cosine 2 theta. Okay, and then lastly, you can do the same trick here with tangent. If I put in theta plus theta, I'd see tangent theta plus tangent theta. That's 2 tangent theta divided by 1 minus tangent theta times tangent theta. That's 1 minus tangent squared theta. So what I see is a formula for double angles for tangent 2 theta equals 2 tangent theta divided by 1 minus tangent squared theta. So these are called double angle formulas because basically what it's saying is if you want to find the trigonometric function of a double angle, twice some angle, you can do that if you just know the trig functions of the angle itself without the 2 in front. So let me try to give you an application of this. Suppose you want to find the sine of 2 pi over 3. 2 pi over 3. Well, I don't know that one off the top of my head, but I do know, and these are in radians, by the way, now I'm going back to radians. I do know that that's actually sine of 2 times pi over 3. Now, pi over 3 is a standard angle. That's actually 60 degrees in sort of layman's terms, but it's pi over 3 radians. So this is actually a double angle. So I can use a double angle formula for sine to see what it equals, just in terms of pi over 3, something I know. Now, by the way, should you memorize these formulas? Absolutely not. Since you've already hopefully memorized the sums and differences, all you do is think about that formula with sum, but replace theta 1 plus theta 2 by just 2 theta. So replace all the thetas, 1s and theta 2s, by just 1 theta, and you get this immediately. So there's no need to memorize all this stuff. Just think about the other formula and plug in theta for theta 1 and theta 2. Okay, so what does this equal? Well, this equals 2 times sine of pi over 3 times the cosine of pi over 3. And those we know because these are all standard angles. So this equals 2 times, well, the cosine of pi over 3 is the square root of 3 over 2. And, I'm sorry, that's the sine of pi over 3 is square root of 3 over 2. And the cosine of pi over 3 is just a half. So I can do a little bit of canceling here. And I see this equals the square root of 3 over 2. So the sine of 2 pi over 3 is actually the square root of 3 over 2. See how I can do that? Before, it might have been a little bit mysterious. I'd have to use sort of reference angle stuff. Here I can just do it using this formula. Let's try one last one. Let's try and cosine 2 pi over 3. Well, now I go to this formula here, or just think about the actual sum formula for cosine, but replacing the theta 1 and theta 2's just by all thetas. And I would see, well, it's greedy, so you first put in cosine squared pi over 3 minus sine squared pi over 3. Okay, well, what is cosine of pi over 3? Well, I already told you that's actually a half. So a half squared is a fourth. And I subtract, and what's sine of pi over 3? Well, I just told you that was the square root of 3 over 2. When I square it, I get 3/4. So what's 1/4 minus 3/4? Well, that equals minus 2/4, or also known as minus a half. So the cosine of this is minus a half. And does that make a little bit of sense? It sure does, because now this angle is actually in the second quadrant, and so the sine in the second quadrant should be positive, but the cosine should be negative. So it all plays out just perfectly. So you can actually use these double angle formulas in a neat way to actually resolve sort of slightly more exotic angles. Okay, we'll take a look at more of these double angle issues up next. I'll see you there.